Dear student, we are going to do the third experiment. The third experiment is estimation of ferrous ammonium sulphate using standard oxalic acid. Okay, as per the short procedure, first enter the all the three column content, titration 1, titration 2. First, the pure solution. Pure solution in both the titration KMnO4, potassium permanganate, that is link solution. Pipette solution for the first titration, 20 ml of oxalic acid, which is standard given one. Then second titration, 20 ml of made up sample, which is ferrous ammonium sulphate, FAS. Additional reagent, here 10 ml of 2 normal H2SO4 for both the titration. Then temperature, normally we conduct room temperature for volumetric titration. Here to avoid the manganese sulphate formation, you have to just heat the solution. It may be 60 to 70 degrees Celsius. For both the titration, temperature to do the titration is 60 to 70 degrees Celsius. Indicator is a self indicator. There is no additional indicator. It's a self indicator. Whatever the permanganate will act as a self indicator. Endpoint colorless to pale pink color. Okay. The equivalent weight of FA is 392. So, titration 1, standardization of potassium permanganate. As per the procedure, you know very clearly, we wash the burette with the water, then rinse with the potassium permanganate with little quantity and fill up to 50 ml. Then we take the 20 ml of standard solution, which is given as oxalic acid, then 10 ml of sulfuric acid we added, 2 normal sulfuric acid we added, and then just we kept it for the heating. Okay, so whatever the heating, it will take few seconds to minutes. So once it's reached the above 60, around above 60, it is ready to titrate against the potassium permanganate. Started to come vapor slightly, that is more than enough, but we may not be able to measure the temperature without thermometer. Just whatever the heat we can able to tolerate without any cloth. Okay, just we can take the conical pulse and started to do the titration. Okay, it's a very simple. So once it's reached the 60 degree, then we, without adding any indicator, we titrate against the potassium permanganate. Now it may be, we have to wait few more seconds to reach the 60 degrees Celsius. In the meantime, the calculation steps just I am telling. So volume of oxalic acid, 20 ml we put up. Burette reading, initial 0, final water we are going to get it, note it down. Then second time the same, volume of oxalic acid 20, initial 0, final, we note it down from the burette. Then calculations, concordant value, we will get it. Okay. So calculation steps, volume of standard oxalic acid 20 ml, normal of standard oxalic acid given 0.1 normal, volume of permanganate from the burette reading A, normal of KMnO4 we calculate. Okay. Then second titration, whatever the second titration is. Okay. So now the sample is getting ready to titrate against potassium permanganate. You see, started to come the vapors. You can able to see the vapors now. I think the sample is ready. Now we start to, if it is little bit hot also, if you are not able to tolerate the hot condition, you can use your handkerchief to hold the conical flask to titrate against potassium permanganate. Okay. Once is add the potassium permanganate from the burette, is supposed to shake very well. without taking much time. Otherwise, it may be form the precipitate which it may be get the endpoint immediately. So we have to shake very well to get proper endpoint, that is the permanent pale pink. Okay. We are reaching the endpoint. Yes, we got it, the permanent pale pink. So very cute color. We got it. Endpoint we got it actually 22.4. Actually upper minister is supposed to take due to the colored one. So it's showing 22.4. Okay. Note down the value. Then once again we will repeat and get the concordant value. Right. Now the second titration procedure I am telling. Estimation of ferrous ammonium sulphate. Burette is washed already, you know. The same potassium permanganate going to fill it. Then made up the ferrous ammonium sulphate using this 100 ml standard flask. Usual procedure. Once we made up, we will prepare out 20 ml of FAS into the conical flask. The same way, 10 ml of 2 normal sulfuric acid, and then heat the sample above 60 degrees Celsius, then titrate against the potassium permanganate. The same procedure will get the same pale pink permanent color, will get it. Now the second time doing the first titration. Okay. Actually we are adding the sulfuric acid. Okay. That is the main reason to prevent the oxidation of manganese to form the manganese dioxide. That is the reason we are adding the sulfuric acid. Okay. So in both the titration, we know very clearly it's a redox titration. Whatever oxidation and reduction happen, when whatever the first titration and second one, first and second experiment, both are the neutralization because acid base titration. Okay, here is oxidation reduction, redox titration. As per the first titration, you know very clearly KMnO4 is the oxidizing agent, and then whatever the addition of acid to prevent the manganese dioxide formation, titrate against the oxalic acid. So it's formed the potassium sulphate, manganese sulphate, and liberate the carbon dioxide. Will get the endpoint. The same way for the second titration, whatever the permanganate titrate against the ferrous ammonium sulphate, FeSO4, NH4 5 SO4, that is ferrous ammonium sulphate, but it's hexahydrate, so 6 water molecule may be attached to the sample, which we are using for prepare the solution for unknown. Okay, with the acid H2SO4 we are adding to prevent the same manganese dioxide formation. Product will get the potassium sulphate, manganese sulphate, ferrous sulphate, then ammonium sulphate with the water. Okay, so here itself is the same self indicator potassium permanganate. So we are going to get the endpoint for the second time of the first citation, standardization of potassium permanganate. You can use the handkerchief to hold the conical flask because sometimes we kept extra few seconds for reaching above 60 degrees Celsius. So don't take any revenge. Just you can use any cloth or handkerchief to hold the conical flask without harm your finger. Okay. This we are getting endpoint pink color. Appearance of permanent pale pink color, we got it. So we get it the say 22.4. Okay, so exactly we got it. Now we'll go for the second titration. So transfer the given FAS sample into the standard flask through funnel using the glass rod. Okay, so FAS sample FAS 1, sample bottle number FAS 1. So wash the sample bottle with a little quantity of distilled water 2 to 3 times, rinse and transfer. Due to the colored FAS solution, you can able to see whether you transferred completely or left over any drops of the FAS sample. If you left, so your answer will be wrong. So better wash the sample bottle with the 2 to 3 times of the distilled water and transfer. Now we shake very well because it added water, 1/3 of water in the standard flask quantity. Then add the distilled water up to the neck. Then shake very well to get homogeneous. Then you can use the pipette for final makeup. Okay. So due to the colored one, you have to use the upper meniscus. Okay, so upper meniscus. Now you shake once again to get the homogeneous. Then we can pipette out 20 ml of made up sample of FAS. Add 10 ml of 2 normal sulfuric acid using measuring jar. Okay, don't pipette out acid. So we have to use the measuring jar. So the same upper meniscus used to pipette out the colored solution and then taken the sample. Okay. 10 ml, 2 normal, sulphate like that. Now sample is going to heat for, okay, sample now it's ready. We can go for the titration against the potassium permanganate. So we got the pale pink color. Value is 18.6 as per the upper meniscus. 18.6. Okay, note down the value. We'll repeat once again to get the concordant value. We put out 20 ml of NADA sample of FAS, 10 ml of 2 normal H2SO4. There is no additional reagent. Titrated against the potassium permanganate, which is self-indicator, will give the appearance of pale pink color. Okay, so here it's actually forming the manganese dioxide. So the temperature is supposed to little bit increase. So we are reaching end point here.